Hi dear students, let's see this question that came in JEE Advanced Physics Paper 2 in the year 2018. The question is from the topic of kinematics. It's a fairly simple question which most of the students would have done under 1 minute. But in this video we are going to see two solutions, and one approach will be using the concept of capacitors. Right, you heard it right. We can do this question using the topic of capacitors as well. So first we are going to see the regular approach, and then we will see how we could have done this using the topic of capacitors. Now the question is fairly simple. There's a mass or there's a block which is at rest initially. The mass of the block is zero point 0.4. The impulse of 1 Newton per 1 Newton second gives the velocity up to the block at time 0, and it starts moving along the x-axis. The velocity varies according to this function v naught into e to the power minus t by tau, where v naught is a constant, okay, and tau is given as 4 seconds. The displacement of the block at t equals to tau is we have to find. Basically, we have to find the displacement of the block at t equals to 4 seconds, and it has been given e to the power minus 1 as 0.37. Now, if we try to find the velocity of the block immediately after the impulse has been given, so we can write the impulse momentum equation. So that will be equals to mv naught. So it is easy to see that if you put t equals to 0 here, so v becomes v naught. That means v naught is nothing but the velocity at time 0. So mv naught is nothing but 1. Impulse is 1. So from here we get v is equals to 1 upon zero point 0.4, which is nothing but 2.5 meter per second. That means the velocity of the block immediately after the impulse was given was 2.5 meter per second. Now we can simply say that velocity whose function has been given as ds by dt. So ds by dt is nothing but v naught into e to the power minus t by tau. So you can take this dt on the right side and integrate. Fairly easy. So at time 0 the displacement would have been 0, and at time t displacement would have become s. So this becomes s is equals to v naught will come outside, e to the power minus t by tau divided by minus 1 by tau. So tau will go in the numerator. 0 say t. So this becomes minus tau into v naught into e to the power minus t by tau minus e to the power 0, which is 1. Let's put the values now, because you have to find the displacement at t equals to 4 seconds. So basically, if you put tau is 4, v naught is 2.5. If you put here t to the t key value tau, so this will become e to the power minus 1, which is 0.37. So 0.37 minus 1. Hence, you see that this becomes 10 into 0.63, which is nothing but 6.3 meters. So answer will be 6.3 meters. So this is the regular approach how to solve this question. Now, let's see the capacitor method. We realize that in an RC circuit, if you try to recall that charge as a function of time is nothing but CV naught into 1 minus e to the power minus t by tau. Tau is nothing but RC. And the current in this case is V naught upon R into 1 minus no into e to the power minus t by tau. E to the power minus t by tau. Tau is RC. Now at time 0 the charge is 0. If you talk about the capacitor which is being charged from the 0 charge. So at time 0 the charge is 0, and at time 0 the current is maximum, okay, whose value is this V naught by R, and the maximum charge is CV naught, okay. So if you multiply this maximum current by tau, you will get maximum charge. You can see if V naught by R is multiplied by RC, you will get CV naught. So this maximum value of the current when multiplied by tau will become maximum charge. Now if you see, the situation is same here. Velocity is acting as the current and displacement is acting as the charge, because I equals to dq by dt and v is ds by dt. No, I is dq by dt and v is ds by dt. Okay, so we can say that if velocity function is given as 2.5 into e to the power minus t by 4, so displacement function can be straight away written as maximum 2.5 into 4, which is 10 into 1 minus e to the power minus t by 4. This is the displacement function that we can write without integration. Now if you put the value of t as 4 here, so you can see that s at t equals to 4 or tau is nothing but 10 into 1 minus e to the power minus 1, which is the same value 6.3 that we have gotten. So this is the second approach to solve this question. I'm not saying that you would have saved a lot of time in this approach, because by method one also it's hardly going to take time. From the perspective of time, this is not much superior. But yes, in any other question in which this particular integration becomes quite difficult, or this particular calculation becomes kind of difficult, so in that scenario this might be super awesome or super handy. In the exam, of course, this is slightly difficult to think, but it's not that none of the students could think like that. Some of our students could think in this manner. So that's it. Thank you.